Okay, good morning. Welcome to
Number 696.
FamilyMath696. So I saw earlier this week a really neat lecture at Harvard by a mathematician named Tim Gowers, who's from England. Have you ever heard his name before?
No.
No. He's he won the Fields Medal in I think 1998, if I remember right. So he's a very highly regarded mathematician and a great lecturer too, actually. Those don't always go together. And so he was talking about intransitive dice, which we've looked at before. Do you remember what intransitive dice are?
Well, they're dice that they're different, and they're not normal dice. So some of them have different faces than the others.
Okay.
So this one has like 4s and 9s.
All right.
This one has 6s and 1s.
I think there's a cycle with these that, like, there's a cycle of dice that one dice, like, I don't know if this is right, but let's say this dice will beat this dice, which 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 will beat this dice. There's a cycle.
Yeah, what's weird? What seems weird about that?
Well, you would think that, like, this is the lowest.
Mm-hmm.
Like, this beats this, beats this, beats this, beats this, beats this, but this one can beat the highest one.
Yeah, and what does it mean that the dice beat the other dice?
Well, when you roll them, you'll get higher numbers.
Generally.
Most of the time. See, this one got a 6. And this one only got 5.
Okay. Yeah, and so we can study those properties, and we can figure out which dice are going to beat other dice. Doesn't mean they're going to win every single roll.
But generally they would.
It means if a yellow dice plays against the green dice, there are 36 possibilities, right? And because there's 6 for this one, 6 for this one, and so we can make a little grid and we can count how many times they win, lose, and tie, and then we can see.
Yep.
See who wins.
All right.
And then, so the question Tim Gowers, and this was not his original question, it was inspired by some people who he was either working with or asked him a few questions about it. So he simplified the question a little bit, so actually it would eliminate these dice. So he said if we're going to look at n-sided dice, sorry about that. We're going to look at n-sided dice. We want the numbers to be from 1 to n on the dice. So you mentioned there was one that had a 9. There it is right there.
And this one has an 8.
Yeah, so these are only 6-sided dice, and this one has a 0. Right? So we're only going to look at ones where the numbers from 1 to n, and there's going to be a further restriction that the sum is n times n plus 1 over 2. What's special about that sum?
Well, that's the sum of the numbers from 1 to n.
Yeah. So for this restriction, give me a 6-sided die that would work.
So, like, if we had, well, a normal 6-sided dice would work.
Okay. What are the numbers?
So 1, 2, 3, 4, 5, 6.
So that would be a valid dice.
Yeah.
Or die. Give me another one that would work that's not equal to this.
Well, we can do 4, 4, 4, 4, 4. So 5 4s and a 1.
5 4s and a 1. Okay. Yeah, because it's got to add up to 21.
Yep.
Right. So 5 4s and a 1 would be a valid one. Can you give me one that wouldn't be valid?
Well, like maybe a 1, 2, 3, 4, 5, 5.
Ah, okay, yeah, because that doesn't add up to be high enough.
Yeah.
And so you wouldn't be surprised if 1, 2, 3, 4, 5, 6 beat 1, 2, 3, 4, 5, 5.
Yeah.
Why wouldn't that be surprising?
Well, it has higher numbers on average.
Yeah, it has higher numbers, so it really should win. So he's trying to look at dice that have the same average number. That's a good way of saying it.
Yeah.
And see if with that you can still find intransitive dice. In fact, the title of his talk, I think, was The Ubiquity of Intransitive Dice, which means, so his question was, are intransitive dice easy to find or hard to find? And he's trying to make it even harder by putting these restrictions on. And given the title of his talk is The Ubiquity of Intransitive Dice, what do you think he found?
some non-transitive dice.
Non-transitive dice are what?
Are pretty.
Ubiquitous,
They're pretty
wide.
wide.
They're,
They spread their.
they're
they're not that rare.
Yeah.
Right, they're not that rare. Okay, good. All right, so let's play around with this a little bit.